Friends, today we are going to discuss a very important aspect for designing a tank. Before going to discuss in detail or the how to design a tank and a different procedure, we want to tell you what are the main load acting on the tank cell to design it calculation thickness. So you see, this is the in tank as it is a atmospheric pressure and not subject to any high pressure. So the liquid level is the prime criteria to find out the cell thickness at the bottom. Because if you see the when the due to this liquid load, uh, the tank is subject to a hoop trace. Hoop trace means PD by 2T. PD by 2T. You see, this is the hoop trace. This is the hoop trace PD by 2T. So P is the pressure, D is the diameter of the tank, and T is the thickness of the cell. So what is P? The P is the internal pressure due to liquid level of the tank or inside vapor. So that P is equal to rho GH. Rho is the rho is the density, G is the acceleration due to gravity, and H is the height of the liquids, height of the liquid inside the tank. So this will give you the pressure, and it will be certainly be more at the bottom, and gradually it will come down. Then next is the picture you depicts. You see your pressure, how it is related. It will be at the bottom because this is the liquid height. This is the liquid height. Here it is minimum, or you can say atmospheric, and then gradually it is increasing because the height of the liquid is increasing. So pressure as the pressure as the pressure is equal to rho gh. So pressure will be maximum here. Pressure will be maximum here. Uh, and then and this is the vapor pressure and others. Wind pressure and shifting wind and seismic pressure is also, or seismic load is also coming on the tank. Next is your due to this pressure, which is bottom more at the bottom. You see the bottom thickness will certainly be more because PD by 2T. If P is more, so naturally your T should be more because add PD D that D is fixed. So T should be T will be more at the bottom. Then gradually the pressure is coming down. So thickness of the required thickness of the cell is also coming down. And this is the as tappers manufacturing of tapper cell, tapper plate is not possible. So this is the additional extra thickness you can say, which we have to, which is not required, but we cannot do anything. We have to select the lowest thickness plate, and this is the actually the hatch portion is the required thickness. And course 2, course 3, course 4 is the differ at the single plate of a high height is width is not possible. So you from the market you have to purchase the different the standard width available. That's why the different courses will come. Next, the very important thing I am going to tell you that is called 1 foot manufacturing process, 1 foot design thickness calculation method. 1 foot. Why we are telling 1 foot? The 1 foot, 1 foot, where the stresses will be maximum. Why the stresses? When we come to know that the height of the pressure will be more at the bottom. Yes, certainly you are correct. But you see the it is anchored. The tank is anchored with the welded with the annular plate, and annular plate is anchored with the foundation. So here your hoop trace will not act. Hoop trace will act. Your trace will be maximum. It is noticed that it is maximum at the at 1 foot or 305 millimeter above the bottom plate, where this cell will behave like a free cylindrical cell, and then your thickness will be maximum. Your stress will be maximum here, and that will govern for finding out the cell thickness. Finding out the cell thickness. It is for the bottom plate, for bottom course of plate, then the top course and the subsequent courses. If you see that the smaller second course is welded with the thicker plate of first course, so this will act as a anchor point. So here also this will not allow to move any free cylindrical cell will not be here. So above it there will be stresses will be maximum. That is at the 1 foot height or 300 millimeter. Similarly for second to second plate thickness is more, so this will anchor, this point will act as a anchor point. So again the 300 millimeter the stresses will be more, and here we have to calculate the thickness of the plates, thickness of the plate. Next is if you see the diagram, stress development inside the plate or in one cell, then you see it is like this. Yeah, it is like this. It will be like this from here to it one course. It is second course. It is third course. It is fourth course. But you see, for the second course also, it is just simply slight peak is there. In the third course also, the peak is there, and the fourth course also there is a peak is there. Means peak is there, but first as the pressure is more at the first course, so 300 millimeter from the bottom of the cell, bottom of the plate, your thesis will be maximum. Thesis will be maximum. Due to this stress, when it is 300 millimeter, it is more. You see, this one is the fixed portion. Here it is not moving, so tank will move in the bulge. Bulge will take place at the 300 millimeter above the first course, above the ground floor, above the bottom plate. So you see, due to this, actual shape of the tank will be like this. Actual shape of the tank will be like this. Now the plates, we are you see the pressure distribution of the due to the level of the liquid at different height of the different courses of the plates, because I think single plate is not possible, so standard plate we have to provide or have purchased, that is 2.4 millimeter, 2.54 meter width will be there. So at 2.4 width, you have to use one by one on plate and weld it. Well, this is 20 meter height. You see, this is 20 meter height plates. For 20 meter heights, these are the number of courses, 1, 2, 3, 4, 5, 6, like this. The courses are there. You see, the distribution, pressure distribution is triangular angle, but your plate thickness will be, you see, the plate thickness will be slightly more. Some wastage, extra plate thickness will be there, but a very important aspect is that as the plate thickness are different, so your projection, you have to match the earlier slides also, we have earlier portions we have told that you match in the inside. Inside, outside you can projection will be there. Outside projection can be permitted because it is not come in contact with the liquid. This is required for two reasons. One is for suppose you are using a floating roof, then if the projection is inside, the floating roof will not move up and down along with the level liquid. And not only that, you want to make a coating inside, then if it is projection is there, your coating will not be perfect. And not only projection is inside, then there is a lot of corrosion will take place, etc. So better to match, it is advisable to match at the inner side, at the inner side of the plate. Then there are formula, I have told you the basic formula, that is hoop trace, the PD by 2T for calculating the thickness. TD, design thickness, it is a 4.9. D, H is the height, D is the diameter, 3 is the factor, calculation factor, G is the specific gravity, C is the corrosion allowance, and D is the design thickness, design stresses. Here you see the 4.9, from where the 4.9 has come. Now 4.9 has come because you have PD by 2T, hoop test PD by 2T. This P is rho GH. G is how much? 9.81. 9.81 means if you PD by 2T, so if you divide the 9.81 by 2, you will get the 4.9 factor. That's why the 4.9 factor has come. In US and for the hydrostatic thickness calculation, you see we have ignored G. because G normally for liquid is 1 and corrosion allowance is not required. So whatever thickness we will get for calculating for hydrostatic test certainly be less than the your design thickness calculation, because here corrosion allowance is there. Corrosion allowance is there. Similarly, for USCU units, United States customer unit, that is 2.6 factor has come. You see the 2.6 factor has come, plus the corrosion allowance for design, and for hydrostatic test corrosion allowance is not there. Where from the 2.6 factor has come, if you see, it is we are doing the thickness calculation as per 1 foot height measurement, 1 foot methods, 1 foot height methods. So distance method. So at 1 foot or 300 millimeter height from the bottom, the liquid pressure will be how much? Now point for 300 millimeter height from the of the liquid, the pressure will be how much? Now 0.433 psi, 0.433 psi, and where D is here in this formula, D we have mentioned at inches. So, but D is here is in foot. So, if you convert it into, because it is psi square inch, so D you have to convert into inch, so it will be 12D, it is foot, so it will be multiplied by 2 to get it inch. So 4.433 into 12 divided by 2 is PD by 2T, so it will be 2.6. So for this reason, the 2.6 factor here come here, and 4.9 has come due to SI unit. Now, design thickness, when you are doing calculation, 1 foot method procedure, then your design thickness calculation by design thickness method, design thickness, so calculation. So at that time, you have to consider the operational load that will include internal, external pressure by seismic and others, internal pressure by vapor pressure, wind, and then your corrosion allowances and liquid levels, etc. That will etc. And when you are doing the calculation for hydrostatic thickness calculation, at that time only liquid level is important. You ignore corrosion allowance and other supplementary loads. There are two methods in which we are doing the thickness calculation. One is called 1 foot method, another one is called variable point method. In 1 foot method is applicable up to 61 meter diameter. Easy to use this direct calculation because you know the hoop trace formula, and formula is also given, and we have to calculate the thickness of the plate at 3.3 meter or 1 foot height from the bottom of the cell, because there the stresses will be maximum, and calculate the stress in conservative than the variable method. Here the thickness you will get will be the more than the variable method. Then the calculation of thickness you get from using the variable method. The 1 foot method will give you the more conservative, means your thickness will be more, and tank diameter often limited by the thickness of the thickness criteria. Is a thickness criteria. And next is your variable point method. Here above 61 method, when your material requirement is the prime criteria, at that time you have to use the 61 meter method. Here the thickness calculation will be less than the 1 foot method, and it is a repetitive method. You have to calculate the stresses at different level of the cell, each cell, and stresses is very close to your hoop traces and permit larger diameter tank for the same maximum thickness. Now, when to use the variable design method and when to use the 1 foot method. There is a the variable design point method may only be used when the purchaser has not specified that the 1 foot method be only used, and when the following is true: L by E is equal to less than equal to 1000 by 6. L by A is equal to less than equal to 1000 by 6. Where L is equal to what? L is equal to 500 D. D is the diameter, T is the thickness to the power 0.5. D is the tank diameter, T is the bottom course thickness, and A is the maximum design liquid level in meter. So suppose your tank diameter is 100 meter, plate thickness is 10 and 10 millimeter and tank height is 6 meter. Your L is how much? This much. L by H will be how much? This divided by 6 is equal to 37.26, which is less than 1000 by 6. Less than 1000 by 6. 1000 by 6 is equal to means 166.6. So here it says that you can use both variable as well as the 1 foot method, but variable method we should not use because a 1 foot method will give you the more conservative and more safety. That's why safety. Only our suppose that's why 1 foot method is should be applicable here. But variable method can be used both below 6 and below 61 meter diameter, below 61 your 61 diameter or above 61 diameter. Both cases it is applicable, but in this particular case normally prefer for less than 61 meter diameter, we prefer 1 foot method, and above 61 meter as the material cost is very appreciable material cost is there. That's why variable method is applicable. Now suppose tank diameter is 80 meter, T thickness is about 90 millimeter, height is 10 millimeter. You see, if you calculate L, then L by each, that is 190/89 method, that is greater than 160.6. That means you have to go for your variable methods. The variable method. But variable method thickness will be less than the 1 foot method. And then how to calculate the variable methods? The formula is there in the 1 foot method. We have already shown, give you one formula, and variable method there is another one formula, that is the empirical formula. Here you see the empirical formula. Here is also D means diameter, A is the hydraulic height, maximum hydraulic height, D is the design thickness, G is the specific gravity, specific gravity, C is the corrosion allowance. Similarly for design, this one is for the design thickness calculation, and this one is for the hydrostatic thickness. Here we have ignored the G and as well as the eliminate the corrosion allowance. So here whatever thickness in design thickness you calculate, it should be less than the thickness calculation by 1 foot method, and here whatever thickness we are going to get for the hydrostatic method, it should be less than the thickness calculation governed by the 1 foot method. And this is one is the thickness of the second course. To calculate the thickness of the second course for both the design calculation, design condition as well as hydraulic test condition, the value of the following ratio shall be calculated for the bottom course of the bottom course. H1 is the height of the bottom course shell, R is the nominal diameter, T1 is the actual thickness of the bottom course. You will get the value and then you can calculate the total thickness of the bottom shell course shall be used to calculate T2 the we have to calculate like this. Now when you calculate the variable method, the thickness, you see that in the market this is the chart available for different thickness plates for different tank height. It are millimeter and feet, and this is your diameter. Is a diameter. If you calculate the diameter, thickness, height, etc. Height. So you can calculate the stress value and then your thickness, and then thickness we have to once the value we have get the thickness, you see the chart where it is in the which plate to be selected. If it is 0.8, then you select this one, 0.87, side more than this. So higher side plate thickness you have to select. This is the so different type of tank diameter, different tank height, different diameter. Your shell thickness will be different, and you have to select from the chart. But one thing, this is very important, that the shell thickness shall not be less than the following. In any case, your shell thickness is coming down. You cannot choose the nearest shell thickness available in the market, but it should be limited to, if it is 15 millimeter, 15 meter diameter, 50 meter diameter, or 50 feet diameter, 50 feet diameter, 50 feet less than 50 feet diameter, then your nominal plate thickness should be 5 millimeter. if you get 3.5 millimeter thickness calculation is come and you can go for 4 millimeter thickness. No, you have to select 5 millimeter thickness, 5 millimeter thickness or 3.16 inches. Similarly, for different dimension, different diameter, the plate thickness has already been mentioned here. This is the, though it is though your calculation come down from this and market is available, but you have to select the minimum. This is the for this diameter minimum 10 millimeter thickness, for this diameter this range minimum this 8 millimeter, for this range minimum 6 millimeter, and less than 5 minimum 5 millimeter, and this thickness is exclusive of the corrosion resistant, corrosion allowances. So you have to add the whatever corrosion allowance permitted, that also to add it with this and then select the plates. Friends, I think I have covered all the aspects required for calculating the plate thickness of tank. If you go through the slides one by one, each slides, your concept will be totally clear. And I have told you the different methods used for calculating the thickness, 1 foot method, variable thickness calculation methods, and the how the pressure at the bottom, PD hook test is acting here, applicable here. Everything we have discussed here. If you are satisfied with these slides, with this post, you please give a tick mark, like mark, or subscribe this channel, because this channel will help you, and in this channel will all the topics, now all the equipment installed in the in your industries, you will be able to find all the equipment will be discussed here. In the tank, you have seen already, you have discussed so many things, and another so many post will going to come. So you please, you are satisfied, you please forward it this channel to get benefit of this channel to your friends, to your colleagues. If you are graduate engineer trainee, if you are junior engineer or experienced also, then also all these all these channels, all these posts will help you to get basic and knowledge, basic and in-depth knowledge for each equipment. Each equipment. If you have still any doubt, you can talk to me. You can talk to telephone me. You can mail me, and you can arrange a video conference so that your doubt will be clear to you. I think. Uh, I think this is the end of this channel. The end of this post. Next post will be on the tank itself. 2-3 posts will come, and then we'll go for pressure vessel, heat exchanger, boilers, and projects, and so many NDT, etc. So please subscribe this post, this channel. Thank you very much.